Our topic for discussion today is a one-on-one interview on the process and benefits of transforming traditional buildings into smarter buildings to achieve peak experiences for the stakeholders. So in other words, max UX. So, I mean, of course, that brings up the questions and thoughts about what are smarter buildings. Well, it depends if you're a university versus you're a office building or a data center. And how do they reduce energy costs and streamline bidding operations to minimize carbon footprint or to improve workplace productivity or even increase, OT resilience or operational resilience? So anyways, these are the things we're going to talk about today for the next 45 minutes back and forth. And this is something we do once a month, typically on the last Friday. And so, for example, on Friday, February 21st, also at 1 p.m. Eastern, we're going to do an assessment and remediation of the gaps in cyber physical security and other operational technology to enable core functions of building workplace for tenants and visitors at the least amount of friction. So anyways, here we are. And Jerry, so when you think about kind of what you have right now, in terms of what they're, you can call them dumb buildings or smart buildings or clever buildings, whatever you want to call them. But when you think about what you have now, and maybe compare yourself to your peers, how are you doing?
Well, I got to tell you, Ari, that I think anybody who's been a practitioner in this space for a while, you always feel like you're behind. And, that's why we talk. That's why I go to many, many events that we overlap with. And, I would say we are certainly not the leader of the pack, but I think we're struggling with all the issues that the leaders are currently struggling with. And I like to think that we continue to learn about technology, across the sphere, whether it's analytics or better ways to set up our networks, whether it's security. But I think we do our best to avoid going down dead ends too far. I like to say we try to find where the limits are as soon as possible, which means we're never really out in the front. But if you can have a way to assess, constantly ask yourself, what am I trying to do here? Because it's easy to get swept up in the fun, in the hype, and build something out that in the end isn't going to save you money or.
No, listen, I mean, you might even be able to avoid spending some money. It's happening with some of the other California universities. I saw a report yesterday that I think UC San Diego avoided a $55 million in real estate spend because they didn't have to improve or add on two additional buildings. All because of occupancy data. So I mean, these are things that can inform our business process and also, inform the HVAC and other systems in the building. Like, don't turn on.
And the thing with universities, there's quite a few stakeholders, right? There's lots of silos. We talk about higher ed being a kind of a short hierarchical thing. It just means there's just a lot of folks. And so, sometimes I'm envious of my, commercial real estate partners who've got very narrow silos and they can go in and just take control of everything and create standards and run with it. We've got some more bureaucracy to work through, but at the same time, we've got a lot of very knowledgeable stakeholders, whether it's environmental health and safety, public safety, HVAC control, energy, sustainability. And when you get those folks together, you can make some really powerful impacts because you start laying over the interests, and where they overlap, you got something good. And we've stumbled across a few of those. And once the value is there, everybody's benefiting. It's not just the operations team or the sustainability team. Yeah, and that feels good.
I want to posit or propose that to get the foundational experiences that people are seeking, the Holy Grail experiences, I'm just going to put an idea past you. It really comes down to two buckets. And maybe it seems too simple, or maybe it doesn't. The first one is ease of access. So in other words, having the least amount of friction for a person to get from their, you know, point of entry, whether it's a parking lot or a bus station or a subway, whatever it might be. Make the ingress and egress, make it easy, make the parking smart. But anyways, ease of access, number one bucket. Number two is the combination of safety and security. So this is both physical and OT cyber, but what does that do for you? Putting things in those two buckets as kind of foundational for the UX.
In higher ed, the culture is always transparency, easy access. People want to come and go. They want to network. They want to experience, and so it presents unique physical and cyber security challenges. Historically, academic buildings, the doors are never locked, right? And so we've had to migrate to a hybrid arrangement where, use the tech, secure those doors, but at the same time, how do we preserve the culture of higher ed where you've got people coming and going to exchange knowledge and ideas? We tend to design things at a campus level, right? So parking, we don't design that at a building level, it's at the campus level. And when we build a building, it's not going to have parking. It's going to be situated relative to the parking facilities we have, or the transportation facilities we have, or our shuttle systems.
Right. It'll be load balance in that regard.
And so, what's key for us is when we have an operation system, you're going to want the HVAC maintenance team to be able to interact with it, and you want the sustainability team and the energy management team, because they're going to be doing analytics on it, looking for opportunities. But environmental health and safety is interested. We have a lot of laboratories here, so we want to keep an eye on hazards that may come out of those. We also have sensitive occupants, right? Our students are very important to us. Our researchers are very important to us, and we want them to have an exceptionally safe work environment. And once you start talking about health and safety, of course, then that brings in security.
Brings in lots of things. I mean, it's indoor air quality. It's the slippage or leaks on the floor.
Yep.
It's the signal strength for for doing the things you want to do with your device. In the inside of the building. It's lighting. It's heck, it's even airflow. Indoor outdoor mix. Lots of things, Jerry.
Yeah.
So I guess when I was reviewing some of your notes, and when you think about this transformation to a smarter building, would it be fair to say that things like room level scheduling are filters? Are like if you're at the point where you can do room level scheduling, then you are therefore a smart building. But do you have rules like that in your mind?
Well, one of those overlap areas that we've really stumbled upon is room level scheduling, because we look at what can we do with occupancy sensors that already exist. Could we deploy new, smarter occupancy sensors that do things like count people or tell where you are in the room? And we talk about this with our space planning partners and various operation teams here. But nothing really seems to stick in terms of let's spend big bucks on this and go for it. But what we've found is that people are very interested to know how a room's HVAC is scheduled. And occupants want to know, building managers want to know, just how is this scheduled, by the way? If somebody, maybe I'm the concierge in the building and the occupants contact me first and they're complaining, sure be nice to know, when does this go into full occupancy mode? Is it 8 a.m., 7 a.m.? When does it go into standby? When does it go into unoccupied? And it's beyond just is, the air handler on or off. It's what is this room doing? And they say, we'd really like to know that. I go, you would? Okay, well, I guess we can serve up that data. Not very exciting, but they say, yeah, it would help me out.
You might kind of baseline information that you can't necessarily use this second, but you might find that some correlations exist, for example, about people, calling in sick because
where it gets interesting is, putting more sensors in our buildings is a privacy thing, and where people just don't like it, right? I don't want anything looking at me. But working with our Office of Sustainability and our behavioral scientists, occupants are willing to provide information if there's a portal that's easy to work with. So if they know, if they manage the building, how their rooms are scheduled, if I'm an occupant, I know how my room's scheduled. I am willing to provide information that says, this is my weekly profile. This is my Monday profile. And I'm not just talking the day, I'm talking about over the course of the day. When do I go to lunch? And with the behavioral work, because I'm an engineer, right? I'm an energy engineer, automation, and you just don't pry into the occupants' world, right? But there are folks that can do that, and they can engage them and say, this is how you can help all of us, make this building more comfortable, make it more sustainable. And you ask questions like, instead of me asking, well, what days do you go home and just mess off, right? You're not paying attention, you're not working. No one's going to answer that question. But if the question's like, what hours of the week would you be okay if your office is in green mode or super green mode? And that's the question that gets asked. When it comes back to us on the automation side, that just tells us go into occupied mode, standby mode, and unoccupied. Right. So all we're really doing is just changing temperature set points. That's all we're doing. And we've done some extensive research the past few summers to know what those impacts are. And we say, all we got to do is if we can just toggle through those settings, we don't need to worry about space temperature optimization per se, right? And we've done experiments there. We don't need to know what the occupancy sensor says. We can do some trimming with that. But if we've got occupants that are volunteering information that says, schedule my room this way, and they want to interact with that data, that's a win, right?
That's a win-win. Sure.
We didn't learn this going to any smart building conferences, but when we just sit around here and talk, the big aha for us in the operations was we never assumed we could have got that information reliably. We would have assumed that, they'll just say run it all the time, run it 24/7, right? And we in HVAC, we got to tighten that down. We've got to be the kind of the police on this, right? And hold them to the fire. But everybody wants to do the right thing. Everybody wants, good buildings, and there's some partnership here. So that's a real recent aha related to, occupancy and how our spaces are being used. And we see this as a toe in for future discussions, right? So this is working. What else can we do? And it is a very significant energy savings potential for us, right? We've got the new automation systems in. We're using, the advanced sequence of operations, and got big savings there. What do we do next? And we really see, optimizing dynamically over the course of the day these occupancy modes. So
I think you could do a lot. I see that when we're not just talking about temperature and humidity and occupancy sensors. There's other sensors in the mix, other IoT on the edge. I see you're using something called Data Orchestrator that you're piloting or doing a proof of concept. Would you be comfortable sharing background on that?
Oh yeah. So for years we've been using fault detection diagnostic software to support our new construction, support existing buildings. Still got some scalability things we're trying to work around. We can't analyze all buildings all the time, but we've learned a lot about getting data out of our BMS and normalizing it, characterizing it, making sure it's easy to flow, get into analytics. We understand the value in high quality data and a good data model. We get it. A lot of work to do, but we get it. And what we're learning now, in just the past few years, we've been doing experiments in our buildings every summer, maybe a dozen buildings, and we'll do bulk command writes to all the rooms. We'll change all the set points in the rooms. Change them this much, change them that much, do a sawtooth pattern over the day, get data so that we can build models on how the buildings respond. Some of these things that we know is intuitive. Well, yeah, if I change the temperature set point, energy is going to change, right? Or the air handler will back off. Of course, that's what happens, but how much? And what's the profile over 48 hours, right? I want to know what happens when I go back to my original set point.
Yeah, and how does that vary by
and to do these
occupancy?
experiments,
So
we had to have an ability to do these bulk both rights, right? Because the experiment's conceived over here in some software, and then it's got to get put into the automation system, and we don't want to have humans having to fat finger in everything. And so we developed some experience, and we use the same infrastructure, right? Our data standards, our data ontology, our tagging, but instead of using it to pull data out to share it with other systems and other consumers, we're using the infrastructure now to push information back into the building management system. So we're not just sending like a digital signal to the BMS, or we're not just writing 1 or 2 points. We are saying all rooms of this type with these attributes, we want this to happen. And so it's a whole layer smarter in terms of using software to interact with the system. So our research team has been fine-tuning a tool to do that over the past few summers.
Right.
And we're like, this facilitates what we're trying to do for experiments. Wouldn't it be nice if we had a production grade tool that we could use going forward? So to further advance our room level scheduling, or to build a more formal demand response program on campus. Are we trying to save electricity? We have district heating and cooling. So,
well, there's all kinds of use cases. There's, you could just do normal hours, after hours, and then crisis, whatever the crisis might be, God forbid a fire, or God forbid, high wind, but you could stress test that based on those three conditions.
And so, for example, having this tool in place, and we're building the next prototype of it right now, but the idea was anybody who credibly understands the building, right? And if they can model their data, it could be public safety. And if they adhere to our data model, they say, listen, we want to lock down all the rooms on this floor, on this wing, right? Well, okay, what rooms? Okay, we know how to model those rooms. These are the attributes. These are the tags. We'll link that to the HVAC system. We link that to the lighting, and boom, we can do that. And so the HVAC automation team, then they use this tool to see what's going on. It's not like this is just happening with no oversight, but now they're overseeing the flow as opposed to having to be a bottleneck in that flow, right? Instead of calling somebody and say, how long would it take to make this change to every building or every room of this type on the second floor? Well,
that's very powerful.
An hour, but let me call a couple techs and we'll get it done. And so it really opens things up. So if you can model the data, if you are responsible for that scope, we can pass it into the system, and it takes a bit of the burden off of the HVAC controls team. So they've always been the bottleneck in terms of interacting with those systems. And so we've talked about democratizing the data in the automation systems, getting them out to more users, make the BMS not be a bottleneck. We want to be able to do the same thing on the inbound side. And so that was kind of the past couple of years, kind of an aha. And you can use a lot of the same infrastructure, but the specific tools to hop the data out, a little different than how you want to hop it back in for simplicity, security, reliability.
So next topic I'm thinking about is the how to improve, or what are the predictor variables to workplace productivity? Whether you're in one of your labs, or whether you're in an office writing a contract, whatever the thing you're doing. I guess my question is, from your perspective, Jerry, what are the predictors of high productivity?
So in higher ed, is a unique vertical. There still is some, how should I say this, credibility to how much space you have as an occupant, okay. Right? It's still a badge of honor, right?
Trophies.
And so, we'd like to use less space, but we still have metrics like, if people are using the building, we know that they are working together. And so some of our best buildings, in fact, the one I'm sitting in right now is a brand new building for our operations team. The best buildings for us, it's not necessarily, how many bodies per square foot. It's how many bodies are the people coming here to interact. They have the option to work at home, but they're coming here. And they're doing that because there's other folks here. And so,
yeah, you want that.
Knowing that your colleagues are going to be somewhere is a huge impact for us. It does make people show up because, again, it's a very flat organization. You've got to be. I mean, it's almost like you're doing sales, internal sales. You're networking with each other. You're talking, and so when we have information on, you know, conference rooms, and we use a concept of neighborhoods in our buildings. So
sure, like
it's touchdowns, limited space, but if you're going to go in and talk to somebody finance, they're probably going to be here today. If you're going to talk to somebody in automation, they're going to be over here today. And knowing that there's people around is incredibly valuable, and that's been our biggest benefit for return to work is just organic. People want to come back.
There's a lot to it. I mean, there's the efficiency of people being there and delaying, a email response or a phone call back. But there's also when you're new to an organization, let's say you're 21 and graduated, and you're coming in, and there's no better, in my opinion, there's no better experience than to be, in person with your mentor. You see how they dress, you see how they behave, how they order food, how they prepare reports, and it's all different,
Yeah. But what is different is the space type even within a building. So for example, we have professional trades that are showing up at 5:30 in the morning, right? And they're staggered, but probably our trades and our engineers, they're probably gone by 4 p.m. at the latest, right? They start checking out at 2:30. But you're going to have maybe some program managers, capital project managers. They may be here till 6. And so that's where it gets interesting is the building has occupants from 5:30 in the morning, probably 6:30 at night, but not all the spaces are being used, right? And so how do we optimize for that? And historically, we know we need to, from an HVAC perspective, we need to zone our labs in one air system, right? And offices in another.
Right.
But now it's like, well, finance people come in and they crank things out on the second floor and they're gone, right? And the third floor, these people, they get up at 10, come to work, and they're not even getting going until after
those
dinner,
are people
right?
doing fundraising.
That sort of thing, and so how do you zone for that, right? Or do you kind of nudge them and say, can you guys kind of just share a space in the middle of the day, work around each other? Because,
the answer is maybe. I mean, the culture tells you what the rules are, unless there's a compelling reason,
And so that's what we're doing now. So even where we have these neighborhood concepts and people have agreed, well, I got a dozen people in my department, but I only need 6 touchdown spots at most. Well, now we're going, well, can you get by with 4? Can you get by with 3? We're still going to have this office. We're still going to have plenty of places for your staff to hang out if they all come in. But we want to make sure when you do come in to hang out, you're hanging out with other folks. And so when we're monitoring occupancy, when we're monitoring use, it's that sort of thing. And then how do we translate that back into good operation of the building? Even if we've got a mothball, half of a floor,
right.
Maybe we're not saving that much, but it's good practice. It keeps the humans interacting. And, so we don't actually put up barriers or anything, but it's like, if we only got a couple people on this one half of this one floor, let's just say we're not using it. And keep those people interacting. And it seems to help, right? Because the more they interact, the more they want to interact. And we're definitely feeling that. And again, at the higher ed, it's hard to force folks. So you could say we do more of this manipulation sort of thing, but it works out.
But I do think that some of these spaces should be, should anticipate, that you have a profile like you have in your vehicle, for the seat back position or the steering wheel. I mean, these spaces, if there's enough information telling you, who's coming in and what the conditions are, I see that. I don't know if that's a high ROI kind of thing to do, but I do see that.
Yeah, we haven't found the use case yet. For using individual information, tying into their cell phone or tying into their Outlook calendar. We continue to look at it, but we haven't nailed down this is valuable. Let's do this.
What about just the cost of, in 1 month, if you whatever occupancy sensor you're using, if you could measure not just the number of people per space per hour per day of week, but if you can also measure the dwell time, how long they're lingering in that space, and I'd be curious if you did that for a month, you might see the biggest save is that, well, you don't have to do janitorial for, I don't know, 15% of the portfolio.
Yeah. Since Stanford being a research laboratory, we're very dominated with labs. In terms of what does our team have to manage, where's the money really, whether it's energy or maintenance. And the early wins we've seen is deploy the smarter occupancy monitoring tech in the labs, because then you get a lot of benefits, right? Because for example, I want to know if there's somebody in there alone from a safety perspective, right? You probably shouldn't be in a lab by yourself.
Alone and at a certain air quality level.
Yeah. So environmental health and safety is very interested in that. And depending on the space, maybe there shouldn't be anybody in there at all at 3 a.m, right? That then becomes
that's a rule.
Public safety thing. Yeah. And so also, we've experimented with infrared technology. Right. And we have a big pushback on any optical based thing here because it's still cameras and we're trying to work through that. But if you're using infrared technology for people counting or something else, that infrared technology can see other things, right? You can see hotspots, right?
Sure.
So I want to know
how the heating and cooling is going.
So if I get equipment on a bench, lab equipment, and it's showing much hotter than it normally is. Or one that I hadn't even thought about is, let's say we have a fire in a chemical fume hood, and the fume hood is supposed to capture that and extinguishes it, and it's safe. But you don't want to have the fire in the first place, right? So can we detect close calls like that? So yeah, we can count people. We can see where they're at. We can optimize the HVAC system. But now we're getting a whole bunch of other folks who haven't worked with us in the past with networked building systems, with IoT systems. And I tell you what, if I get, senior director from environmental health and safety, and I get a director of public safety, and they say, do what these HVAC guys want to do, it's going to happen, right? We're going to get the budget, we're going to put the sensors in. And that's really where I think that's going to be continue to be where we're blazing the new trail. Is we're going to start in the labs, get a lot of buy-in, a lot of support, start to build out our infrastructure, and then work its way back into the offices and in the classrooms.
Yeah. I mean,
the other issue is there's just a lot of cooks in the kitchen, right? Well, some people say, the best thing to do is we really need to get the university to okay, device tracking, look at the Bluetooth signals and stuff. But that's a big fight in itself. And others, it'll say, what we need to do is we need to deploy a whole bunch of wireless indoor air quality sensors anyway, and we'll have these incorporated with some occupancy monitors. And that's the right way to do things. And so it's bureaucratic in the sense that everybody's trying to take the high road and they're arguing over what the best high road is. So you do run into some stumbles there.
I mean, the process side of me says, if you ask the question, what is the decision we're trying to make? So, we need a certain amount of data. We don't need too much, but we don't need too little. So yeah. Do we need occupancy data? Yes or no?
Yeah.
If we do, what level of precision do we need it?
Yeah. Coming out of COVID, for us here, our number one driver is resilience. And that incorporates a lot, right? We want to be able to use the space. It does incorporate safety. And, my team knows a well-maintained building, a building that's resilient is going to save energy. We see those connections. And so usually when we talk about smart tech now, it is, how do we make this space more usable and reliable if there are wildfires or if there's a, power issue in the local grid.
So Jerry, when I walk into, let's say, the civil engineering building, is there any place that me as a visitor can see what's going on in the lobby, like in terms of basic parameters?
We've got some pilots, but no, we don't have a standard kiosk experience yet for the occupants. But we do have, how should I say this? We built in processes and procedures that are, shared with our occupants in terms of if you are in this building and if there's an outdoor air quality excursion, this is how your space is impacted or usually not impacted. And that's kind of the message we want to take, right? This is the way your HVAC system works. This is where your air comes from, which again, it's nice having the hierarchy, and the control system usually is if you want to have a good as-built of what your HVAC single line looks like, it's going to be coming through the HVAC control system. So we basically tell them how their building works and say, listen, if you are concerned, you're better off coming to work than you are staying at home, and this is why. So we'll do that. When
you normalize the rate for whether it's electricity or water or some other utility, yeah, I don't know if you can say this, but I'll just ask, what % difference is it in 2025 versus 2019? Again, with a normalized dollar.
I guess in terms of spend.
Yeah, because the number of people on campus is about the same, right? You have more buildings, but the number of people. I'm just saying system wide. If you're just measuring kilowatt hours or some other unit.
We're seeing year over year a pretty steady increase of about 1.5%, and we did see a little bit of dip during COVID, but I think like a lot of commercial building operators, that dip wasn't nearly as much as we would have expected. And, many of our buildings had to keep running because they had research going on in them or they had researchers using that. But, our growth trend has continued. We like to think we were constraining the growth. We'd like to think it'd be probably 2.5% a year if we weren't doing our aggressive demand side programs and automation updates and things like that. But we probably only had maybe a 10% dip during the middle of COVID. It really wasn't that much.
I'm kind of glad. I mean, it's a pretty open campus. A lot of it's not. I mean, it's spread out over many acres. And
one thing to keep in mind, because of our climate, we have a lot of housing here, a lot on campus, but we don't have to do much climate control in our housing. So, if those are occupied or unoccupied, it's not like they were big loads to begin with. Say if we would.
So next topic on the quiver of transformation tools. So the central group that you've created, how much are you using digital twins to maybe start to increase the productivity?
Oh, that's a good question. So I think we're doing what could be called our first digital twin, and we're just doing it in a couple buildings. And basically, we've gone from energy modeling to what I would call simulation. And where we cross that line, I don't know exactly.
So with people by time of day, all that.
And so, for example, we've done hourly energy models for new construction buildings, for retrofit projects. We've done that for a long time. What we've just started to do is generate models that are of high enough quality that I call them prescriptive, meaning when I run that model and I put in the weather forecast for tomorrow, I'm going to know how that building's going to perform within a reasonable bandwidth.
Confidence level, right.
Typically, when we've done modeling in the past, everything averages out over about a month, right? I can model the month of July really well, but, it's going to give some funny answers any given hour. And so being able to have, but again, something that's got prescriptive value, forecast value is new for us. And first, we do that just with, we calibrate to our actual energy meters, we calibrate to occupancy, we calibrate to weather. Where we're going next is we're actually going to ingest the HVAC data into that model and calibrate against it. So that's going to increase our number of points, like, 2 orders of magnitude.
Yeah.
But now we'll be able to incorporate which air handlers are running, what's the load, which pumps are running, which systems are on. And now we're simulating how that building works. And people are getting interested because we've done this through my energy management team and my HVAC automation team. They see the value too. But what gets interesting is if we can model energy, we can model things like what's the return temperature to our district hot water system and our district chilled water system. Sure. These are incredible variables. Sure. They've historically been very, very hard to model, if not impossible to model. But if we've gone into this realm now of a true simulation, and we can teach that model, we've suddenly opened up the possibility to optimize our distribution systems, not just the energy consumption, but how the building is using its chilled water, how the building is using its heating hot water. And those usually feed forward into, there's something acting wrong in this building. There's some valves that are stuck open. There is something that's just not right. So people say, well, are we doing a digital twin now? I scratch my head. I think maybe we are,
right.
And
I'm
this
curious,
is how we got it. And we didn't get into this from, I need a 3D visualization tool for my BIM models. I mean, of course we want one, we've dabbled with that, but it didn't stick. What stuck is I want to be able to do a reliable hourly forecast for this building for the next 24 hours. And I also want to be able to start predicting and forecasting things that we've never even thought of doing in the past. And we see some good value there. I can do it for 2 buildings now. If I can get it up to 100 buildings, or our top 200 buildings are about 95% of the energy, 95% of our capital renewal, whatever you're counting. If I can get those modeled, I now can feed that all back into our central energy facility, which currently has an hourly optimization software platform, which is very sophisticated. And then I can actually start doing building level demand management. I can do building level projects.
Sure.
And forecast exactly what's going to happen, plug that back into our central plant. And we've got thermal energy storage and other demand management things. So a lot of our future optimization, it's unintuitive. The software needs to solve for what's our dollar cost saving, what's our 24 real-time carbon impact. Being able to model things in this kind of this modern world, is the software's got to do it. You just can't say, oh, I'm not going to use electricity during the afternoon. That doesn't work anymore. There's situations where we may say, you know what, if we don't use electricity between 2 a.m. and 4 a.m. on Thursdays in Northern California, we're going to have a big impact on carbon in the region, right?
I would imagine your account would be full. I mean, your carbon credit account. I mean, you've been doing this for years. I mean, are you banking these? Are you able to package them and resell them?
So the Stanford has 2 large power purchase agreements out in the Central Valley in California, plus some on-site PV. And so we produce more kilowatt hours per year through solar than we consume. So excellent. Obviously, how the power markets work. We got to sell into the market where we make it, and then we buy out, and the RECs and the accountants make that really complex in a hurry. Our concern now from a sustainability standpoint, we're still members of the Northern California grid, right? Mm-hmm. And that grid's got a profile to it. And while we're technically 100% renewable on our electricity now, we are still pulling power at night, right? And so how do we help, the community at large going forward, and if the rules get changed on how you count your carbon. But the only way
you
to
have to
do
be able
that
to
is
bank those, and then they get distributed
we
based
got to have
on.
the digital twin to do that.
They're getting easier to make. I've seen them created, demoed to me, and up and running, where you can actually use your phone, even your cell phone to scan a schematic. You might draw by your hand, or you might have a proper schematic, and less than a minute later, you now have a functioning digital twin where you can choose the materials on the walls, change the window types, place cameras, place other IoT.
Yeah,
So I mean,
the software modeling tools are getting easier. I personally can't use them. They're getting easier to use for smart, technical building engineering people. But the way the tools work, they're like a kit, right? So you got one module where you're going to make the physical structure, right? And somebody can do that on their own pretty quick. And then you're going to have schedule, and then you're going to have these other input parameters. Then you're going to have, what's your data model, right? How do you describe your HVAC points? And so light work in any one of these areas, and you don't have to have all of them, but if you do have all of them, suddenly it's a pretty robust tool, and the software is affordable. It's no longer kind of a specialty niche thing. In fact, just about any large project now is going to have a BIM model, and
for years,
that's going to have not only kind of the graphical arrangement, but it's going to have a bill of materials, and
and the structure itself has to be,
and you can generate a points list.
Sure.
Right now, that's not going to be 100% aligned with your final controls infrastructure, but this is what you can do now just with construction drawings: is spin up a pretty sophisticated baseline model, and then you tweak from there.
So maybe to close out, and the large elephant in the room is always ROI or break even or some way to monetize. So have you been in a position where you have been able to group or create affinities of things that, for whatever reason, when you spend money this way, going from a dumb to a smart building, you expect a higher ROI? Have you developed any kind of any observations?
Yeah, the step one for any smart building is you got to get a good OT network in there. You got to get good basic BMS system in there, lighting controls, and we got a good 20 to 30% energy savings right off the bat there. We continue to tweak, but really, when we think benefit, it's these multiple wins. So, for example, nobody even counts the dollar savings we get from using advanced analytics to commission new construction buildings or to do retrofit, large retrofit projects. The savings is so dramatic. It saves, the general contractor time. It saves commissioning meetings, post-commissioning. It saves warranty problems. So everybody just knows I need to have this software up and running as soon as possible because I want to get the benefit, and everybody has that attitude.
One of the comments I'm seeing here from one of the participants is that BIM is too expensive for most companies. True, false? What do you think?
I could see that. I'm not in the construction side, but the nice thing is you don't have to have the BIM either, right? And I think you were touching on this. Is you can spin up a basic physical model of your building and then tweak from there. And I would encourage people to look at that again. Kind of folks who've been in this industry for a while, like me. I'm not going to learn the new tricks, but I've got some computer science interns, and they're just falling in love with the built environment. They go, "This is fascinating. Look at these tools you got to play with. Look how much potential you guys have got. You're barely scratching the surface."
It's almost like a video game. They're creating like a set for a video game.
They go, "Jerry, you know how easy this is?" I go, "Probably." But it's good feedback, right? The tools are there, and you don't have to have perfection to have a tool. You don't have to have everything. You don't have to spend 18 months getting your software perfect to get any value. You can get some value after just a few weeks, and grow from there. But again, ROI, Ari, it's kind of like, if our resilience and response team wants data on the operational status of a building, whether it's which ones have power, which ones don't, which generators are running, which ones aren't. People don't ask a lot of questions. We serve that data up, we structure it, we get it out of our BMS, we get it into the campus's GIS system so they can put it on the main, the big user interface, right, that everybody interacts with. So we get cases like that where you don't have to justify it. When the entire university wants building status information on a public portal, it's going to get there. Nice. And that's when it gets exciting. So is each one of those a digital twin? No. Are we doing the absolute bleeding edge technology? No. But guess what? We've got probably 10,000 people who are now benefiting from what was simple to a couple people.
Right. You want it to be seamless to the end user.
Yep.
But also the implementation, you want to lower your risk profile wherever you can. So, well, this is good. It's a good conversation. I know we'll do this again. A few questions come up, but I think we're clear. Okay, so I want to thank everybody for participating on this webinar sponsored by KMC Controls, and thank Jerry from the Facilities Department at Stanford University, and myself, Ari, representing KMC Consulting. Thank you again, and have a safe week.
Thank you, Ari. Bye-bye.
Bye.